Hey guys, so this is just a video to recap the angle relationships that we have talked about in class. So in that case you were not here. So what I'm going to be talking about today is from your vocab sheet on the back. We're going to be talking about transversals, alternate interior, alternate exterior, corresponding, and consecutive interior angles. So you have the vocab sheet to refer to along with diagrams, but sometimes it's helpful to see what we talked about in class. All right, so in this first diagram here, I have line 1 and line 2, and then line 3 here, which I've highlighted in pink. That is what's called our transversal. A transversal is a line that intersects or crosses two or more lines. It has to cross two, right? And when that happens, once you have that transversal there, you have what are called your exterior angles and interior angles. So I could name these by letters BGA, that angle, BGC, okay? But to kind of save time, I'm going to go ahead and write in numbers so that way I can talk about them a little bit easier instead of naming the angle by the letters. All right, so my exterior angles are the ones outside of the line. So angle 1, 2, 7, and 8 are my exterior angles. My interior angles are 3, 4, 5, and 6. Now, alternate exterior angles are angles that are outside and opposite of the transversal. So angle 1, so the one we need to go on the opposite side of the transversal, okay? But you almost have to be in the opposite position as well. So they can't be next to each other. So alternate exterior would be 8. So 1 and 8 are alternate exterior angles. The other pair of alternate exterior angles is angle 2 and angle 7. They are on alternate sides of the transversal and they are outside of the lines. Now, the inside angles are 3, 4, 5, and 6, the interior. So we have angle 3 and its alternate interior is angle 6. And then we have angle 4 and angle 5 are also alternate interior angles. All right, so those are the definitions and kind of how we would look at those in those locations. The other thing, and I'm going to try, let's see, highlight it in orange. Yeah, I guess we'll do orange. Is we also have what are called corresponding angles. So if you take a look here, corresponding angles, they, but those are more specific to the parallel lines too. They have relationships, but corresponding means that they're in the same place. They're on the same side. So for example, angle 1 and angle 5 are in similar positions and they're on the same side of the transversal. So that's corresponding. Okay. So 3 and 7 would be considered corresponding. They're in similar positions on the transversal. So 2 and 6, 4 and 8. Then we have consecutive interior. Well, consecutive means in a row and interior means inside. So we want angles that are in a row inside. So they're also going to be on the same side of the transversal. So 3 and 5 are consecutive interior angles. 4 and 6 are consecutive interior angles on the other side. Okay, so that vocabulary really applies to any time angles are formed from a transversal intersecting two lines. All right, now notice the difference between this diagram and this one. Okay, we have this symbol here, which means 1 is parallel to 2. We also have this symbol on the line that's saying, hey, this means that this line is the same. It is parallel to this line. So I have indicated in 2 places that these 2 lines are parallel. I don't have any markings on this diagram up here to say that. And even visually, we can see that if I were to extend, they would eventually cross. So we can do the same kind of thing and identify our vocabulary in this diagram as well. I'm going to go ahead and number them just like I did in the diagram above, okay? Just so that way I can refer to them by numbers instead. So I'm going to take a look at alternate exterior angles, angle 1 and angle 8. when I take a look at them, right, I'm going to lay this piece of plastic over them. And when there's parallel lines, there's actually a special relationship. So if I trace this angle, okay, angle 1. Now, remember in some of our definitions, oops, that glares a little bit much there, sorry. I can move this, now that I have this plastic, I can kind of move it around to see where else does it match anywhere, kind of like a puzzle. I see it doesn't work with 2, even if I kind of try to turn it this way. It doesn't line up, the vertex doesn't work, but it does line up and match with angle 4. Well, that's because they're vertical. And vertical angles, as you've learned before, are congruent. So they share a vertex. Now, if I slide it on down to angle 8, I notice that it's also the same measure. So alternate exterior angles are congruent. Okay? So, and actually, you know what? Let me go into a back diagram because that is where I already have it labeled for you. So we're talking about alternate exterior angles. So we had 1 and 8. And I can show you there's angle 8. And if I turn it, I did not redraw it or anything, it matches up with angle 1. Okay? So the conclusion we can come to is that angle 1 and angle 8, well, since they are exactly the same, that means that alternate exterior angles are congruent. That is the sign for congruent. It's an equal sign with like a enye symbol. So that also means that angle 2 and angle 7 will also be congruent. So if I erase that and I trace angle 2 and I rotate it around, I see that it matches up with angle 7. Okay? Sorry for that glare with the plastic. All right, so alternate exterior angles are congruent. That lets me know. So if I know that this angle right here is, I don't know, 70 degrees, that means that I know that angle 8 is also 70 degrees. And from there, I know that angle 5 is 70 degrees because it's a vertical angle, and vertical angles are congruent. So it kind of creates like a connect the dot about how you can figure out missing values. So now let's take a look at alternate interior angles. So my alternate interior angles, all right, angle 3, well, alternate means opposite side, and interior. So yes, 4 is on the alternate side, but it can't be next to it. So we're kind of like in opposite sides and opposite lines in a way. So angle 3 and angle 6. So let's take a look at that same idea and trace that. Okay, and if I were to rotate that around, I see that they're the exact same angle. So angle 3 and angle 6 are congruent, which means that angle 4 and angle 5 are congruent. So in conclusion, alternate interior angles are also congruent. Okay? Congruent is the geometry term for equals. I'm not really sure. I guess geometry wanted its own symbol. Maybe you could find out why we have this symbol and not just an equal sign. All right, now again, notice this was for parallel lines. If I were to go back to the diagram that did not have parallel lines, we'll see that this does not work. So for example, if I trace angle 1 right here, okay, according to alternate exterior, it should match up with angle 8. Now, they kind of look similar, but if I line up the vertex, you can see it's a couple of degrees off. All right, and I can also check even, well, angle 3, let's check our interior angles. Okay. That one, you can't really tell because of my black marker, but it's slightly over. So those look similar, but not quite it. It's like off by maybe a degree. All right, let's see. What about 4 and 5? Let's trace those. I need a skinnier marker. Okay. Again, because of the thickness, you can't really see through that it's off by ever so slightly. So the point is that these relationships that we're looking at only work if they're parallel lines. So exterior angles, without a doubt, are going to be congruent if you have parallel lines. If you have parallel lines, interior angles will be congruent. Right? So now let's take a look at corresponding angles. Corresponding angles, remember, are on the same side of the transversal in similar places. So for example, angle 3 corresponds with angle 8. And if we take a look at angle 3 and angle 8, if I trace that angle, it's literally just sliding it on down till it finds its match. And we see that they match there, okay? And I could do the same thing and turn that, like on the other side, angle 2 would correspond with what? That's right, angle 6. And we can see that they match. Alrighty? So we can conclude that corresponding angles are also congruent. So if you can identify the relationships, you can find those missing values. Some other examples of corresponding: angle 1 and angle 5. You have angle 2 and angle 6. And then we have angle 4 and angle 8. Those would be your corresponding angles. Okay? As they're on the same side of the transversal in similar positions. The last set of relationships that we're going to take a look at are consecutive interior angles. So again, consecutive means in a row and interior inside. So we want to still be on the same side of the transversal. So for example, angle 3 and angle 5 are consecutive interior. Okay? Angle 4 and angle 6 are also consecutive interior. Well, in the other ones, we noticed that they were congruent. So let's test out that idea there. Let me see if I get a different marker if we can see the angle measure a bit better. Use red. Okay. Now, if I try to rotate it and I line the vertex up for angle 5, we can definitely see that it's not working out. So they're not congruent. Okay. But, well, let's take a look at what we know from before and those inside angles. So let's go back to alternate interior. What's the relationship between 3 and 4? They're linear pairs, so they're supplementary. They add up to 180. So that means that this angle plus this would add up to 180. Well, what's the relationship between angle 4 and angle 5? They're alternate interior angles. And alternate interior angles, we found out, were congruent. So angle 4 is the same as angle 5. Well, if 3 plus 4 equals 180 and 4 equals 5, that must mean that 3 plus 5 will also equal 180. So consecutive interior angles have a sum of 180 degrees. Right? So those are your main relationships when it comes to angles of parallel lines. They're either going to be congruent or they're going to add up to 180. That's really kind of what it boils down to. So hopefully now that will help you as you try to find your missing angles.